Hello friends, and welcome to this second session on time, speed and distance. We have already covered the definition of speed, right, and also seen the relationship between distance, speed and time. We have also studied the variation which happens when there is a variation in distance and speed, right, or when there is a variation in time, how does speed varies, right? We have seen the relationships and we have solved few questions on that as well. We have also studied the definition of average speed and solved few questions on that. What we are going to cover today is the concept of relative speed and then few test cases basically on trains and races. What we would be left with is clocks and circular motions, which we would do in another video. So let's go to the concept of relative speed. Without going into any definitions or something like that, let's first understand a scenario, right? So imagine you were going to a school with your friend on your bicycle, right? And your friend is 1 kilometer ahead of you and he is pedaling at 5 kilometers per hour. So you want to catch him up, right? And that too in 5 minutes. At what speed should you start paddling so that you are able to catch him up in 5 minutes? So how do we solve this question? That's the important thing. So imagine that your friend is, you are here, right, at this position. Let's call it position A. Your friend is at position B, right? So this arrow marks your friend, right, and the distance is 1 kilometer. Now you see that you are also paddling, your friend is also paddling, which means that you would meet somewhere at point C, right, which is this arrow. You would meet at point C. So your friend would travel from B to C and you would travel from A to C. What would be constant for both of you? It would be time, right, because the time taken by your friend to travel from B to C is the same time which you take to travel from A to C, which means your speed is higher than your friend, right? So if you are given options, first thing which you have to check is look for the options which are greater than 5 km per hour. Let's say all the options are greater than 5 km per hour. Then how to solve it? Now let's say you catch up with him in 5 minutes, right? So which means if your speed is what is the distance which is traveled by him in 5 minutes? It would be 5 into 5 by 60. This would be the distance which is traveled by him in these 5 minutes, right, which is 25 by 60. So this is equal to BC, right? And AB we know is 1 kilometer. So what you have to travel is AC, right, which is equal to 1 plus 25 by 60, which is equal to 85 by 60, right? So you have to travel this much distance in this much kilometers in what time? In 5 minutes, right? Which means your speed would be 85 divided by 60, right? This is the distance, this whole divided by time, and time is given to be 5 minutes, right? So 5 by 60, which means your speed has to be 60 would get cancelled and your speed has to be what? 85 by 5, right, which is equal to how much? 17 kilometers per hour, right? So this has to be your speed so that you are able to catch him up in 5 minutes, right? I hope that you understood how do we solve it normally. Now what is happening, right? This BC is covered both by you and him, right? So what effectively is covered more by you is AB, right? So had your speed and his speed is same, right? So for example, you are also traveling at 5 kilometers per hour, when he reaches C, the distance between him and you would also again be 1 kilometer, right? So the distance between you is not reducing. Now since you are traveling faster than him, the distance between you and him are reducing, and it would become 0 at C, right? Before that it's not reducing. So if we write the equations, let at any time t he is traveling what, 5t, right? Let's after any time t he is traveling 5t, right? And you are traveling st, right? So this is the difference between you, and this has to be 0, right? But initial distance between you and him is 1, right? So this means this has to be 1. So this is equal to 1, right? Which means s minus 5, we can take t common, into t is here given to be 5 minutes, right? So 5 by 60 should be equal to 1, right? Which means s minus 5 is equal to 12, or s is equal to 17, right? So this is just the concept of relative speed. Again, what we are doing is, you are traveling at a speed s, he is traveling at speed 5, right? So after t time, the difference between you and him should become 0, which means if you travel st and he is traveling 5 minus st, the difference, which is 1 kilometer, should be covered. So it is equal to 1, right? If you solve it, it comes out to be 17. We again can do it using the concept of Cartesian planes, right? So let's assume that A is point 0, right? A is what? It's 0. And B would be then 1, right? So this is point 0 and this is point 1, right? And let's say C is some point in future where A and B both reaches, right? So now how do we do it? Let C be point C only, right? So C minus 0 is the distance traveled by A, and this is equal to st, right? C minus 1 is the distance traveled by B, the friend, which is equal to 5t, right? So if we subtract this, C and C would get cancelled, and what we are left with, 1 is equal to st minus 5t, right? So again the same equation which we earlier wrote. So what we are effectively doing is, since me and my friend are traveling in the same direction, the relative velocity or relative speed would become s minus 5, right? So this is the relative speed, and the relative distance which we have to cover is 1, right? So that's the relative distance, and this has to be covered in 5 minutes, right? So in 5 minutes, with this relative speed, we have to cover 1 kilometer, which is the relative distance. So we put this equation. So that's what relative speed is, right? So relative speed in general means my speed relative to his speed, right? So I am traveling, I am going from A to A1, A to A3, and he is also traveling from B to B1, B to B3, and eventually we meet finally at C, right? Imagine that he is constantly sitting here, right? So what I would require only is to cover this 1 kilometer, nothing more than that, right? But now since he is also traveling, the distance between me and him is changing as well, right? So to make things easy, we assume that he is not traveling, he is stationary, right? So to make him stationary, what I would do is, because we are traveling in the same direction, I would subtract his speed from my speed to get the relative speed. And the distance between us initially is the relative distance. So that's the concept of relative speed. I hope that you understood it. It is a bit confusing, but don't go by definitions. Just try and solve few questions and I'm sure you would be able to do it. So this is the case when we are traveling in the same direction. We subtract the speeds. Now let's take another example. Two trains traveling at 60 and 90 kilometers per hour respectively. If they are 300 kilometers apart, in how much time will they meet, right? So they are 300 kilometers apart. If first, now they would meet at certain time, which means again time is constant, right? So time is constant, which means the ratio of the distances would be in the ratio of their speed. So the ratio of the distances would be 60:90, which means 2:3. So they would travel in 2:3 time, right? Now the 2:3 distance, right? Now 60 kilometers 60 km per hour is the speed of first train, 90 km per hour is the speed of second train, and they are traveling in the opposite direction. So we would define speed relative as sum of these two speeds, which is 60 plus 90, and this is equal to 150. So relative speed is 150 and relative distance between them is 300. So they would meet after 300 by 150, which is equal to 2 hours, right? So this is the relative speed when they are traveling in opposite direction. So the rule is simple: when they are traveling in opposite direction, we add the speeds. When they are traveling in same direction, we subtract the speeds, right? So now the ratio of the distances traveled by them is 2:3. We know that the total distance traveled by them is what? 300, right? So the first train would travel 2/5 of that distance, which means 2/5 of 300, right? Which is equal to 120 kilometers. So 120 kilometers is traveled by the first train, and 90 kilometers is traveled by the 180 kilometers is traveled by the second train. So first train travels 120 kilometers and its speed is 60 kilometers per hour. So how much time does it take? It takes 2 hours, right? 120 divided by 62. The second train travels 180 kilometers at the speed of 90 kilometers per hour. Again, it verifies our solution that it would take 2 hours. So both of them are taking 2 hours to travel a total of 300 kilometers, right? So to make things relatively easy for us and to make thinking easy for us, we introduce the concept of relative speed, right? So what is actually relative speed? So the distance is covered linearly by both the trains, right? So for example, at any time, after any time t, the 60 kilometer train would cover 60 t, right? And 90 kilometer train would cover 90 t, right? Which means total they are covering 150 t, right? And this 150 t should be equal to 300, right? So t is 2 hours. That's what we are doing, right? Rather than writing 60 t plus 90 t, what we are doing is we are adding the speeds beforehand, right? And make it equal to total distance. So that's the concept of relative speed when they are traveling in opposite directions, right? I hope that you understand the basic concept of relative speeds. So there are just two rules: when they are traveling in same direction, subtract the speeds; when they are traveling in opposite direction, add the speeds. Let's go to next question. So this next question is related to length of the trains, right? So you see, a train has certain length as well, right? So generally when questions of train are asked, it is assumed that train has certain length, and when we say that how much time does a train requires to pass a lamp post or a person, we assume that from the beginning to the end the train passes the person or the lamp post completely, right? So let's say there is a lamp post A, right? And we have a train. Let's copy this. and let's paste over here. So this is the initial position of the train, right? So this is the head of the train just at A, right? Now when it is complete, when we would say that it is completely passed, when the position of train is something like this, right? So then we say that the train has completely passed the point A, right? Right? So in this question, this A is a lamp post, right? And it takes 3 seconds to pass this lamp post, means to cover this much length, right? So this point A, let's say this point, right? This point of train, this arrow, the head of the arrow has now become this. So what it has traveled? It has traveled the length of the train, right? In 3 hours, right? So we say that the speed is 60 and the time taken is 3, right? Or it would be, let's put it 30 to make it more simple. So it's 30, right? 30 seconds. So we have to convert it in hours, which is divided by 3600, right? So the length of the train is 1800 divided by 3600, which is equal to 1/2 kilometers, or which is equal to 500 meters. So this is the length of the train. So these are the concept of train questions, right? Now if we amalgamate the concept of train question with relative speed, how do we do it, right? So it says a train traveling at 60 km per hour crosses a man riding a bicycle at 10 kilometers per hour in 60 seconds. So both man and train are traveling in the same direction. The speed of train is 60, the speed of man is 10. Relative speed would be 50. So SREL would be 50, right? So to cover this relative speed and the distance would be, again the man can be now considered as a single lamp post only, right? So if the man is the lamp post, in 60 seconds at 50 kilometers per hour relative speed, it is covering the distance which is equal to speed of length of the train. So let's divide it by 60, 3600, right? This becomes 50 by 60, right? Which is equal to 5/6 kilometers, or 500 by, or it would be 5000 by 6 meters, right? Which is equal to 833.33 meters. So this would be the length of the train in this case. Again, since the man was traveling in the same direction as the train, we have to find the relative speed, and the relative distance of the train was again the length of the train, right? So this is how we find the solution to this problem. Now in another case, there can be question where the train is crossing a platform, right? So in that case, there is a train and there is a platform as well. So this was the train, right? Let's say this was the train. It entered a platform, right? Let's say the platform is also here. So it entered a platform, right? And finally it left a platform. The final position of the train would be something like this. Let me paste it. So the final position of the train would be something like this, right? So this is the platform the train entered, right? Initially it was at the beginning of the platform. Finally the tail of the train was at the end of the platform. So this arrow now has traveled what length? It has traveled the length of the platform plus length of the train, right? Right? So this arrow has traveled length of the platform plus length of the train, right? And in this question it says in 60 kilometers it crosses the platform in 60 seconds, right? Which means in 60 seconds how much length it has crossed? This is 250 meters. How much length it has crossed? It is 60 multiplied by 60 divided by 3600, right? Which is equal to 1 kilometer. Out of this 1 kilometer, 250 meters is the length of platform. So what is the length of train? It would be 1000 minus 250, which is equal to 750 meters. So length of the train would be 750 meters. So these are few cases of train questions, and once you practice this, I am sure you would be able to do these questions very easily. Now let's go to another case, which is the question on races, right? Here you would hear the words like A beat B by this much kilometers or this much meters, or A beat B by this much time, right? So let's understand the terminology first by solving this question, right? The question says in a race of 100 meters A beat B by 20 meters. What does this mean? This means that when A has just reached the final mark, which is 100 meter away from the starting point, B has just covered 80 meters, right? Which means in the same time A has covered 100 and B has covered 80, right? And the A has beaten B by 20 meters. So B has fallen short of 20 meters before reaching the final destination, right? So this is the meaning of this question. We have to find the ratio of A and B. Now what is same for both A and B? It is time, right? So when time is same, ratio of speed of A and B, let's say the speed of A is A, speed of B, is equal to the distance traveled by them, right? Which is 100, B traveled 80, so which means the ratio of their speed is 5:4. This is as simple as that. Nothing hi-fi about this question, right? There can be another question in which it is mentioned that in a 100-meter race A beats B by 15 seconds. Again he is asking us to find the ratio of speeds of A and B. What do we mean by A beat B by 15 seconds, right? So let's say A takes T time to reach from starting to end point. B would take T plus 15, right? Now what is same for them? They have covered 100 meters, right? So the ratio of their speeds would be inverse of, so A ratio B would be T plus 15 ratio T. Since we don't know T, we cannot simplify it further, and hence we cannot find the ratios in this case, right? Had it been given that A covers the distance in, let's say, some time and B takes 15 seconds more, right, then we could have find this ratio. Now let's go to the next question, which says again in a 120-meter race A beats B by 15 seconds. If the ratio of speed of A and B is 2:3, find speeds of A and B, right? So A beats B by 15 meters, which means if ratio of A and B is equal to T plus 15 by T, right, which is equal to, it has to be 3:2 because A speed has to be higher than B speed, right? So this is equal to 3:2, right? So we will find T, if we solve it, is equal to how much? T is equal to 30 seconds, right? So this is the time taken by A to cover 120 meters, which means speed of A, which is denoted by A, would be 120 by 30, which is equal to 4 meters per second. Similarly, we can find the speed of B, which is equal to 120 divided by 45, which would be equal to how much? It would be 8 by 3, right? So it would be 8 by 3, which is equal to 2.66 meters per second. So this is the speeds of A and B. Again, you have to just see that in first question, in some cases the distance would be the same, in other questions the time would be the same, and accordingly we have to find the relationship between the speeds, right? That's how we do such questions. Now let's go to the next question. Here we have three entities, A, B and C. It says A beats B by 20, which means speed of A ratio speed of B should be equal to 10:8, which is equal to, if we simplify, is 5:4. B beats C by 10 meters, which means B ratio C is equal to how much? It would be equal to 100:90, or it is equal to 10:9. What we have to find is A ratio C, right? We have to find is A ratio C. We have to find the distance by which A beats C. The A would beat C in the same ratio as the ratio of their speeds, right? So we have to find A ratio C, right? So A ratio B is given, B ratio C is given, right? So if we multiply both these, right, A ratio B into B ratio C, we would get what? A ratio C, A by C, right? So this would be equal to 5/4 multiplied by 10/9, which is equal to 50/36, right? So ratios of the ratios of speed of A and B is 50:36, or we can write it as 100 ratio what? It would be 72, right? So if A covers 100 meters, B would cover 72 meters only, right? C would cover 72 meters only. So A would beat C by how much distance? By 28 meters, right? So this would be our answer. So seemingly complicated question, but if you understand that by what distance does A beat C, what does this statement mean? This means in the same time, if A covers 100, how much distance does C cover, right? So what we have to find is, because time is same, the ratios of speed of A and C and distances covered by them would be in proportion, right? So we would just find A ratio C, where A is the speed of A and C is the speed of C, right? Which is coming out to be 50:36. So if A covers 50 meters, C covers 36, but A has to cover 100 meters to complete the race. So eventually C has to cover 36 into 2, which is 72 meters, and hence it falls short of A by 28 meters, right? So this is as simple as that. You don't have to go into hi-fi fundas and all that stuff. Now another important question or interesting question in this is A beats B by 20 seconds, right? So if A takes time t, what would B takes? B take t plus 20 to complete the race. By what time? C, and B beats C by 10 seconds. So if B takes t plus 20, C would take t plus 30, right? Simple. A takes t to cover that distance 100 kilometers, 100 meters. B takes t plus 20, right, to cover the same distance. Now it says B beats C by 10 seconds, which means if B takes t plus 20, C would take t plus 30. The question asks, by what time does A beats C? Now A is taking t, C is taking t plus 30, which means A is beating C by 30 seconds. So seemingly difficult question, but the solution is of just one line, right? You have to write these stuff and write the answers as 30 seconds only, right? So this is how we do questions on speeds, right? Just understand which of the parameters out of distance and time is constant and find the ratios of the speed. That's the formula of doing it, right? Next question says, so this is an interesting question. There are pretty one or two methods of doing this question, and we'll see how to do the questions. So in a kilometer race, A can beat B. A can give B a start of 100 meters or 15 seconds, right? So this means if A and B are 100 meters apart and they start racing, A and B would complete the race in the same time, right? Or if A starts 15 seconds after B starts, again they would complete the race in the same time, right? How long does A takes to complete the race, right? Now if A gives B start of 100 meter, which means A has to travel a kilometer and B has to travel 900 meters only. So the ratio of the speed of A and B would be 1000 ratio 900, which is equal to 10 ratio 9, right? Similarly, A gives B a start of 15 seconds, which means their speed, if A takes T, B would takes T plus 15, right? This is what is meant by this, right? So these are the two equalities of A ratio B. So if we equalize them, which means T plus 15 divided by T is equal to 10 ratio 9, right? So this means T is equal to 135 seconds. If we solve it, T would come out to be 135 seconds, right? So that's what we have to find. How much time, how long does A takes to complete the race? So A takes 135 seconds to complete the race. This is one method, which is a conventional method. Now if you look very closely, it says A can give B a start of 100 meters or 15 seconds, which means what? Which means in these 15 seconds A would cover this 1000 meter, right? So B would require what time to cover 1000 meters? It would require 150 seconds. That is the time required by B. B to cover 1000 meters, right? And what time does A require to cover 1000 meters? 15 seconds less than him, right? Which means A would require 135 seconds to cover the same distance. So to cover 1000 meters, A would require 135 seconds. So this is a shortcut, right? Even if you don't understand this right now, I'm sure you would be able to do that with practice. So you can stick to the normal way out and start solving the question. But if you understand the trick, things become very easy, right? So this is the trick to solve this question. Let's go to next question. So things are becoming more and more complex with each question. So this is the beauty of this unit, which is time, speed and distance, that we have only one formula, but we are using the concept of ratios and proportionalities in it, and we are using the concepts in a very intelligent way, right? Slightly complicated question, right? Which says two friends A and B leave from P and Q simultaneously, travels towards Q and P at a constant speed. They meet at a point in between the two cities and proceed to their relative destination in 54 and 24 seconds respectively. How long did B take to cover the entire journey from P to Q? Right? So let's go to this diagram, which was the train diagram, right? So here so let's say this point is, let's clear this. This point was P and this point was Q, right? They meet somewhere here at a point, let's say R. So this point is R. I'll again, right? So A travels from P to R, B travels from Q to R, right? Now they continue, keep traveling from R to P, and A keeps traveling from R to Q, right? This is what is given. And what further, I'll just copy the question here only so that it becomes easy for us. So what it says further is, now it says is A travels from P to R and B travels from Q to R in the same time, right? In this the time is same because they started simultaneously and they reached a point R simultaneously, right? They meet at a point, let's say this is R, and then they proceed in the directions, right? So A started to move towards P, or B started to move towards P, and A starts to move towards Q. So to travel the distance PR, B takes 54 minutes, right? And the two, then they proceed in their respective direction. So B takes 24 minutes and A takes 54 minutes. We have to find the total time which B takes to travel from Q to P. So that total time should be 24 plus something, right? So it has to be higher than 24. Just check the options if options are given. If there is any option which is below 24, you have to just cut it down. So how to do it? Seems to be a very tricky question, right? So if the speed of A and B is A ratio B, right? The speed of A ratio B, let the speed of A be A and B be B, right? So the ratio would be equal to PR by QR, right? So that's the ratio, because when they are meeting at R, they are taking the same time, right? So that's the ratio of their speeds, right? Now we can also say that speed of B is equal to, so B has to travel PR and it is taking 24 minutes, and A has to travel how much? A has to travel RQ, right? Or QR, and it is taking 54 minutes, right? So we can also say that A ratio B is equal to how much? QR by 54, this whole divided by PR by 24, right? So this is also the ratio of their speeds, which comes, if we simplify it, it comes out to be what? So this is divisible by 6, and this is also divisible by 6. So this would become 4 QR divided by 9 times PR, right? And this is equal to PR by QR, right? So from here we can find that PR ratio QR is equal to, so PR ratio QR we can find it equal to 2:3, right? Now what we are given is, to cover this PR, right, it takes 24 minutes, right? It takes 24 minutes. So to cover PR, which is equal to 2x, it takes how much? 24 minutes. We have to find how much time does it take to cover total PQ, right? So PQ is how much? PQ is equal to 5x, right? So to cover 2x it takes 24 minutes. To cover 5x it would take 24 divided by 2x, this whole multiplied by 5x, which is equal to how much? 60 minutes. So that's how we solve it, right? So we again are using the variance of speed and distance, right? Because time was constant, we were able to find the ratio of PR and RQ. So this is the simplest method. You can have many other methods to form equations and all that stuff, which would not be very efficient. So this is the most efficient method, which I think you should follow, right? So that's how we do this question. Now let's go to the last question of this session, which says car A trails car B by 50 meters. Car B travels at 45 kilometers per hour. Car C travels from the opposite direction at 54 kilometers per hour. Car C is at a distance of 220. So there is a lot of information. You might be confused with this information, so try to break it down by making a diagram. If car A decides to overtake car B before car C and B crosses each other, what is the minimum speed at which A must travel, right? So this is just amalgamation of all the concepts which we have learnt. I would leave this question to you. I hope that you can do it very easily, and we'll discuss this question in one of the assignments. So this is all for the relative speed module of time, speed and distance. What is left is circular motion and clocks, which we would be doing in another video. I hope that you enjoyed the video, you got the concept of relative speed right, and you would be able to solve most of the questions of trains and races. Thanks for watching this video and all the best.